Talofa, welcome to Stats Chapter 14, Linear Regression Chapter. Now this problem helps us to read the Minitab and also helps us to clarify the concepts of linear regression. Starting with question number A, on average, each inch taller a parent is, the children is about that much taller. How do we find that out? We just look at the linear regression equation. We can see that if parent increase by 1, that adds to the multiplication of 0.7853. Therefore, the child is about 0.7853 inches taller if each inch taller the parent is. So for B, so usually we're doing the test concerning the slope. So they want to prove if the slope is not equal to 0. That's why we choose this answer. And for the test statistics, we just copy the t statistics here and then put it down here. And p-value is very small, so it's approximately 0. So we can just simply put a 0 there. And since it's lower than 0.05, that's why we reject the null hypothesis, and there is sufficient evidence of an association between the parent height and the student height. So now they want to test if the slope were 1. What would that say about the association? For each inch taller a parent is, the child is about an inch taller. So think about if this slope becomes 1. So for each inch the parent is increased, then it would add to the 1. So this is the null hypothesis. And to calculate this test statistics, this new one, we need to keep in mind an equation. T equals to beta 1 minus null over standard error beta 1. So T equals to, in this case, this one minus 1 over the standard error coefficient. So it's just that, and then we'll calculate a number like this, and then when we round it up, it will give us this answer. And since that number, if we do it as absolute value, is greater than any of these critical value of t, that's why we can estimate that the p-value is less than 0.05. And so we reject the null hypothesis, and there is sufficient evidence of an association between the parent height and the student's height. Thank you for watching.